Good evening, everyone. Let me come to my introduction first. My name is Akshay Kumar S, and I've done my MTech from BMSc in Power Electronics branch. And today I'm going to give demo on time, distance, and speed. Okay, so this is a topic. So we know the relationship between speed, time, and distance. Speed is nothing but distance by time, and we can also write time as distance by speed. So we should also be worried about the units here. So how do we measure speed? So the practical unit will be kilometer per hour, or the SI unit will be nothing but meter per second. Now you need to know how do you convert from kilometer per hour to meter per second. Okay, so how do we convert? So we know the basic conversion that 1 kilometer will be equal to 1000 meter, and 1 hour will be equal to it has 60 minutes and each minute has 60 seconds, so it will be 60 into 60, it will be 3600. So whenever you're writing any competitive exam, so basically what do we do is we just write or multiply whenever you're converting kilometer per hour to meter per second, we multiply that by 5 by 18. And what if you want to convert from meter per second to kilometer per hour? If that's the case, we'll take the reciprocal, that is just ulta. We'll multiply that by 18 by 5 and get the required answer. Okay. So for example, suppose if I want to convert 90 kilometer per hour to meter per second. So 90. So I'll multiply this by 5 by 18. So it will be 18 ones are 18 fives are. 5 into 5 will be 25. So 5 into 5 is 25 meter per second. So this is the calculation. So this is how you convert kilometer per hour to meter per second. Okay. Next is the average speed. Now what is this average speed? So average speed is nothing but the total distance traveled by the body to the total time taken by the body. Okay, so whatever the total distance that the body has covered up, and what is the total time that it has taken to cover that particular distance. So using this, we can get the average speed here. So whenever you want to calculate average speed, so there are certain things like, okay, so we might have cases where the distances covered, okay, might be unequal, like it is unequal intervals of time, or equal distances in unequal intervals of time, unequal distances in equal intervals of time. So these are some of the possibilities, so that you need to consider before calculating the average speed. Now for example, suppose if you keep the time duration same, and a body has covered a certain distance at a speed of x kilometer per hour, and the same distance has been covered by another body or the same body at the speed of y kilometer per hour. So the average speed in the entire journey will be nothing but just x plus y by 2. So average speed, for such a thing, okay, so is x plus y by 2. So x plus y by 2 kilometer per hour. So this will be the formula. This is a formula for average speed. Now what if for example, like suppose the distance is fixed. Okay, I am covering distance of 100 kilometer at a speed of x kilometer per hour. I am also covering another 100 kilometer at a speed of y kilometer per hour. So in this case, so what will be my average speed? Okay, so average speed will be nothing but the harmonic mean. So how do I calculate? Is nothing but it is 2 by, so harmonic mean is nothing but if you take speed as x and y, so your according to harmonic progression, it will always be 1 by x and 1 by y. So it is 1 by x plus 1 by y. So this is my formula for average speed. This is the formula. Now suppose if I take LCM in the denominator and rearrange, so formula will be nothing but 2xy divided by x plus y. So this will be the formula. Next, what if there are 3 different speeds covering the same distance? So in such case, it will be 3 by, it is xy plus yz plus zx. Okay, so it is better to remember this formula so that it will be helpful. So this is the formula. If a body is covering a certain distance at speeds of x kilometer per hour, y kilometer per hour, and z kilometer per hour respectively. Next comes the relative motion. Okay, so when two bodies are moving, so we'll always tell that one body is faster than the other, or one body is slower than the other, and we can tell one body is traveling at a speed double the other body, one is traveling at a speed half of the other body. So these are the relative comparisons whatever you have. So in relative motion, the one thing you need to remember is when two bodies are moving and they're moving in the same direction, your relative speed will be nothing but x minus y kilometer per hour. And when the two bodies are moving in the opposite direction, So then the relative speed of the two bodies will be nothing but x plus y kilometer per hour. Okay, and like the problems that you face is like the train problems. How, for example, a stationary object is held at a station, and a train, how much time does a train take to pass through the entire object? Okay, so suppose if I consider that point to be like no dimension, the point which is having no dimensions, in such a case, so the time taken by the train to pass that entire point will be equal to the total length of the train. Suppose if the speed of the train is x and the length of the train is L and the time taken to cover is t, so which is nothing but the formula is nothing but x is equal to L by t. Now in some cases what will happen is, suppose the object has some dimensions, like it has width or length of a meters. In such case you need to add up along with the length, because it has to pass through the entire body. So the total length will become L is the length of the train and a will be the length of the object. It is x is equal to L plus a by t. So this will be the formula, x is equal to L plus a by t. Now what if both the objects are moving? So if both the objects are moving and if they are moving in the same direction, train A is moving at a speed of x kilometer per hour and train B is moving at a speed of y kilometer per hour. So now in such a case, so how do I calculate? Okay, so I need to consider the length of both the trains also. If the length of train 1 is L and length of train 2 is A, so in that case if they are moving in the same direction, formula will be x minus y is equal to L plus a by t. So this is because they are moving in the same direction. This will be the formula. And you can also have x plus y is equal to L plus a by t. Suppose if the trains are moving in the opposite direction. So these are some of the problems that you might face. That is, like they might ask questions based on this particular concepts. Next is downstream and upstream. So we have a boat and we have a stream. So we call it downstream and we call it upstream. So when the boat is moving along the way in which the water or the stream is also moving, we call it as downstream. If you are moving again, if the boat is moving against the direction of the flow of the stream, it is said to be upstream. And whenever the boat is moving downstream, so what will happen to the relative speed? It will increase. That is, whenever the body is moving in the downstream part, it will be x plus y. If I consider the speed of the boat as x kilometer per hour and speed of the stream as y kilometer per hour, so speed downstream. So your speed downstream will be nothing but x plus y kilometer per hour, and your speed upstream will be nothing but x minus y kilometer per hour. So this is your x plus y and x minus y. This will be the formula. Now using this concepts, so I'll give few examples like what is the type of problems that they might ask you. Okay, so the problem they might ask you is like this. Suppose if they tell you that suppose a boat goes 30 km upstream and 44 km downstream in 10 hours. So the total journey is 10 hours. So in 10 hours it has gone 30 km upstream and 44 km downstream. Again another boat, so it goes 40 km upstream and 55 km downstream. So I'll consider the same boat itself. Okay, but it goes 40 km upstream and 55 km downstream, but it will take 13 hours. So they're asking what is the speed of the stream and what is the speed of the boat. Okay, so let me see what will happen in this particular case. In this type of problems, so since the given data is in terms of time, so time is nothing but distance by speed. So my equation will be distance is first is 30 km and speed upstream is x minus y, and downstream is 44 and speed downstream is x plus y. So addition of both the times will be nothing but 10. So this will be my first equation. 30 by x minus y plus 44 by x plus y is equal to 10. My second equation will be nothing but 40 by x minus y plus 55 by x plus y, which is equal to 13. This is my second equation. X is the speed of the boat, y is the speed of the stream. So you got equation 1 and equation 2. Now there are two unknowns. As a result, there are two equations here. So once I solve these two equations, you might tell the equation looks complex. So I'll tell you that. So you can do one thing. You can take 1 by x minus y as u and 1 by x plus y as v. Here also 1 by x minus y as u and 1 by x plus y as v. So your equation will simply be nothing but 30u plus 44v is equal to 10 and 40u plus 55v is equal to 13. This is what your equation will be. So these are two simultaneous equations. Solve this. First you'll get the values of u and v. So we'll discuss how to solve this in the later part. Okay, so again u and v. So solve this and get the value of u and v. Once you get the value of u and v, you can get the values of x and y. So this is the approach you need to follow. Next will be nothing but another train is, they say that an express train. So they say that there's a express train and there's a passenger train, and it is going from Bangalore to Mysore, and the total distance is 150 kilometer. So and they say that the express train is 11 kilometer per hour faster. It moves at a speed which is 11 kilometer per hour faster than the passenger train. That is like if your passenger train is traveling at 60 kilometer per hour, this will be traveling at 71 kilometer per hour. So now in this particular thing, so what will be your equation? So equation will be nothing but, suppose again time. So it is 150 kilometer. Let the speed of the passenger train be x kilometer per hour. So time will be distance by speed. So it is 150 by x. So time taken will be 150 by x. Next, what is the time taken by the express train? Again the distance is 150, but the speed at which it is traveling is 11 kilometer more than the normal train, passenger train. So it is x plus 11. So it is 150 by x plus 11. So they say that the difference between these two times is 1 hour. That is, your express train will reach 1 hour faster than your passenger train. So since your obviously this T1 has to be greater than T2. This is your passenger train, this is your express train. So the difference between time, that is T1 minus T2, will be 1 hour. That is, if passenger train takes 4 hours to reach the destination, your express train will be reaching in 3 hours itself. So it is 150 by x minus 150 by x plus 11, which is equal to 1. This will be my equation here. Now I have to solve this. So how do I solve this? Suppose if I take LCM and do all the calculations here, so it is x into x plus 11, which is equal to 1. So I'll do all this calculation. So I'll get a quadratic equation. So just solve this. So your equation will be x square plus 11x is equal to 1650. So this will be my equation. Suppose if I solve this quadratic equation, x square plus 11x is equal to 1650. So this is a quadratic equation. If I solve this quadratic equation, so I'll get two roots. One will be positive and one will be negative. So speed cannot be negative. So I'll take the positive answer. So even when you're solving this particular quadratic equation, make sure that you know that trains usually travel at speeds of like 70, 80, 90. So put those particular numbers. So you'll be able to find the roots in a much easier way. Okay. So this is just a small demo. So thank you for watching and hoping for a positive response. Thank you.